Okay, this is sample problem 1611. In this one, it says an aqueous solution of a strong base has a pH of 8.15 at 25 degrees Celsius. Calculate the original concentration of base in the solution. A, if the base is sodium hydroxide, NaOH, and B, if the base is barium hydroxide, BaOH2. Now notice with this one, they're asking you for the pH of a base. Now, you might say, well, wait a minute, it's a base. Shouldn't we do POH? And the answer is yes, we do the POH calculation with a base. However, most measurements that are made with pH meters, not POH meters. So we tend to report acidities based on pH, not POH. So here's what we'll do. We'll calculate the POH for each of these. And then once we've calculated the POH, from that we'll calculate the concentration of each base. Okay, concentration of the base. So let me show you the first one. How do you go from pH to POH or POH to pH? Remember, we have this relationship, very simple one. pH plus POH is equal to 14. As long as we're at 25 degrees C. That 14 value is a property of water. Water has a Kw of 1 times 10 to the negative 14 at 25 degrees C. Therefore, pH plus POH is equal to 14. Okay? So, if the pH is 8.15, and we're talking about bases, the POH would be 14 minus the pH. So that's 14 minus 8.15. 5.85. So that's the value of the POH that we're trying to figure out here. So let's do part A. Part A is sodium hydroxide, strong base, and the POH is 5.85. So since it's a strong base, the concentration of hydroxide is going to be equal to the concentration of sodium hydroxide. So we can figure out the sodium hydroxide concentration just by finding the concentration of hydroxide. And how do we do that? Well, concentration of hydroxide is 10 to the minus POH. It's a nice relationship. So that would be 10 to the negative 5.85. Anti-log. Okay, so we come back over here. 5.85. We want to make that the negative, right? So negative 5.85, and then we go anti-log is 10 to the x. 1.4 times 10 to the minus 6. And that would be equal to the concentration of sodium hydroxide. Now, for that given concentration of sodium hydroxide, we now ask the following question. What would be the concentration, this is part B, of barium hydroxide that gives us a pH of 8.15, which is a POH of 5.85, right? If we read the question, it says an aqueous solution of a strong base has a pH of 8.15. So that's the same pH value. Now we want to find out what the concentration of barium hydroxide would be. But we're figuring it out from the hydroxide. If the POH is 5.85, that's the concentration of hydroxide, right? So what's the concentration of barium hydroxide? Well, let me show you. When barium hydroxide dissolves, you get 1 barium and you get 2 hydroxides. So in a sense, this problem is like asking you the following. If you have 10 wheels and you're going to make bicycles out of it, how many bicycles can you make? if you have 2 wheels and you make 1 bicycle out of 2 wheels. Okay, I'm sorry, let's make it 10 wheels. Sorry. 10 wheels, and there's 2 wheels for every bicycle. You could make 5 bicycles, right? We're going to do the same thing here. If the concentration of hydroxide is 1.4 times 10 to the minus 6 molar, right? We already figured that out in part A. Then what's the concentration of barium hydroxide? Well, this is a 1 in front of it, and this is a 2 here. So this is 1/2 the concentration, right? So 1/2, let me write it over here. Let me make a little space here. We'll erase this. So it's 1 barium hydroxide for every 2 hydroxides. And the amount of hydroxide we have is 1.4 times 10 to the minus 6 molar. So that would be 7.0 times 10 to the minus 7 molar barium hydroxide. So in other words, the amount of barium hydroxide you need to dissolve to give us a pH of 8.15 is half as much as sodium hydroxide, because you get twice the amount of hydroxide from barium hydroxide as you do from sodium hydroxide, right? Like this only gives you 1 hydroxide. This one gives you 2 hydroxides. So you only have to put half as much of this in to give you the same pH.